All right?
Do what you want.
Because surprisingly, we're going to do the derivative of the inverse trig function. And for Shania's sake, I'm not proving this to you because we don't have time today. We don't know. But you would expect that if you're doing the derivative of an inverse trig function, that you would get trig functions, right? No. No. You get 1 over the square root of 1 minus x squared. And like I said, actually I'll probably show you this to you next class so you have some idea of why on earth would we go from an inverse trig function to that. I'll give you the hint. You remember when I made you draw all those trig functions and we had like sine is y over r, and then we figured out the third side was Pythagorean theorem was 1 minus x squared. So when we end up doing the derivative here of this, we actually end up having to do the trig function we end up with. End up doing a r over x, and so we end up with 1 over 1 minus x squared. It comes from drawing those pictures.
Mrs. Meyer, is that Karen on the board?
Yeah.
Is she actually on the board?
Yeah.
Whoa. Does she know that she's on the board?
Yep.
Wow. Karen is on the board. She always gets her hands down and very responsive. Very responsive.
Squared. The good news is the inverse cosine derivative is the exact same thing, except you slap a negative on it. So you'll get negative 1 over the square root of 1 minus x squared. That's the good news. You really only have to learn 3 of these. Tangent turns out to be 1 over x squared plus 1. So what's cotangent going to be? Cotangent is indeed negative 1 over. Yeah. Focus, Isaac. Thank you. I don't have a clue what he's talking about. Okay, and secant turns out to be 1 over x times the square root of x squared minus 1. Which means cosecant is a negative 1 over x times the square root of x squared minus 1. Now, what's going to be the problem? You really only have to learn sine, tangent, secant then, because you know the codes put negatives on. But how do you keep all that straight? And, well, I had a class, I can't really remember exactly who it was, that invented this story. And I don't know why we were discussing Romeo and Juliet, but we were. So, this is the Romeo and Juliet story to help you remember your inverse trig function. Okay? When you're in the root, you're in Juliet's room. The little root symbol is her balcony. Okay, so that's her balcony there. Okay, so when she's sinned, sign is sin, she's sinned, she's hiding in the back of the room. It's 1 minus Juliet. She's back there hiding. Okay. So down here on secant.
Oh, when she's tanning, she's in the front of the room, so she's in the sunlight.
When she's in tanning, she's in the front, and she doesn't have a root over because she's tanning.
Oh, I knew it. Oh. I caught that. Wow.
And then Romeo is speaking her, secant. He's speaking her. And so, and actually, I forgot to write here. That's in an absolute value. So he has his ladder with him. The absolute value is his ladder. He's climbing up her balcony. And of course, she's out here right at the edge of the balcony waiting to meet him.
Someone came into your class and was high.
So, I'm sorry, that should be absolute value too. So, it helps. We tend to remember it better. She's sinning, tanning, or seeking. Or he's seeking.
I was wondering what you're going to do with that little X there.
Okay, now, somebody usually says, do we have to use those special quadrants we learned? You know, Cody sells cocaine, that whole thing? Okay, yeah. But you'll notice, are these capitalized? No, we are not using the limited quadrants. We are doing all quadrants. So we're not worrying about necessarily, is it always a function? So you don't have to sweat that. So all you have to do is be able to do derivatives with these, knowing those particular 6 rules. So, here we go. couple quick choices. I have an inverse sine of 7x to the 5th. Okay, she's sitting, so she's in the back. She's in the back of her room. Okay, so the derivative of the inverse sine is 1 over, it's the square root of 1 minus, but here's the change. Because we have something other than an x in there, we have 7x to the 5th, you will put in place of x, you'll put that 7x to the 5th, and then it gets squared. Okay, now, the other thing you're not done with, though, this is a chain rule. That's the derivative of the inverse sine. Now you got to do the derivative of its inside. So you actually have to times by and do the derivative of the inside, which would be 35x to the 4th. So if you clean that up, you end up with 35x to the 4th over the square root of 1 minus what? There, somebody said it, 49x to the 10th. Go ahead and square that out. And ta-da! You have constructed your derivative. Are we going to die from that?
Probably. I couldn't even figure out the last side of it.
Yeah. Yeah, so in other words, if I don't go crazy on what I put inside of it, it's not bad. Really, usually the inverse trig functions are not a big issue. This is probably one of the easiest things in this section.
Really?
Yeah. Once you get them learned.
Oh, there's the fine print there.
Okay, so I'm doing this inverse cosecant times an inverse tangent. That is a product rule, yes. So that's what we have to start with, because we have a trig function times inverse trig function. So yes, I do a product rule, so I'm going to write down first. Okay, derivative of the second means the derivative of an inverse tangent. She's tanning.
She's outside.
Yeah, she's outside, she's in the front. And so in our case though, instead of being x squared here, it'll be what's inside that, it'll be natural log of x squared, whole thing squared. Plus 1, she's I don't know, she's adding to her looks here, so it's plus 1. Okay. And then yes, I have to multiply then by the derivative inside. So what's the derivative of natural log of x squared? 1 over x squared times 2x. Okay. Plus, I'm going to have to go out here. So I would write the second one down. The whole inverse tangent thing gets written down. Okay, now I'm ready to do the derivative of the first, which is an inverse cosecant. Okay, so you're thinking secant, she's seeking.
He's got to climb the ladder.
He's got to climb the ladder. So what's inside the ladder, the absolute value? So the absolute value export. Now, they technically, because x to the 4th is a positive, is going to make it come out positive. The book would not write that absolute value there since it's going to be positive. I am fine if you go ahead and keep it there. Not essential. So there's that times the root. Once again, I have to have, it's supposed to be x squared, so now I have to do x to the 4th squared minus 1 when she's inside the room. And then, looking at the original, we just did the derivative of inverse cosecant times the derivative inside, which is nice and easy. 4x cubed. Yeah, 4x cubed. Now, if you have one that messy, I'm not going to expect you to clean it up, because that's nasty. You can leave those. You don't need to attempt to clean that up. Although you could cancel an x with the x squared right here, but we'll live with those. Okay, that's inverse trig functions. Okay, we are starting L'Hopital's rule. And we're doing much, much more L'Hopital's rule next class. Ah, thanks, Isaac, for adding to that story.
I'm making it work for me personally.
Well, he's saying if she sins, she's hiding in the back because she doesn't have anything on. Okay. What am I on time with? Okay, we're good.
I was sharing it with Alex because we have very like minds.
Uh-huh. Okay, we're going to actually have a whole bunch of indeterminate forms. Today we're supposed to get all three of these done. We aren't going to get all three of these done. If I can get you through the first two, I'll be happy. Okay. This is actually, it can be a really good thing. Okay, I'm going to give you a limit we did back a chapter ago when we were doing limits.
Is this on our journal somewhere?
I'm sure it is. Okay, we did this last chapter. When you do a limit, you're supposed to sub the number in, and what will you get here? 0 over 0. Okay, and we were able to solve this then by factoring and canceling. So I'm going to come down here a second and do that. If I had factored and canceled this, I had x plus 2, x minus 2, x minus 2 cancel, and I end up with 4. Okay, but you can also now do this by L'Hopital's rule. Because L'Hopital actually proved that if you're doing the limit that approaches a number, and it's a fraction, you got something over something, you will get the same answer if you do the derivative of the top over the derivative of the bottom. You'll still get the same answer.
Wait, what?
So, let me show you this. It's kind of funky. If I did it with this problem, as long as it's an indeterminate form of 0 over 0 or infinity over infinity, you can do this.
Okay.
What's the derivative of the top? Derivative of the top is 2x. What's the derivative of the bottom? 1. Don't do a quotient rule. Whatever you do, this is not quotient rule. It's derivative of the top, derivative of the bottom.
Why would they change it up like that?
Because it's cool.
No, it's not.
Put the number in there. What do you get?
Ridiculous.
4. Same answer.
Neato.
And that's actually way faster. And a lot of times it is way faster. Didn't have to factor in all that stuff. But it has to be a situation where you have 0 over 0 or infinity over infinity to do it. Okay. So, let me...
What did you show us during our limits thing?
Because you didn't know derivatives when we were doing limits.
Yeah, we did kind of.
Well, I taught them to you a year before, but... Okay. You are going to find particularly useful these lovely limits that I made you learn. If you're going to positive infinity, what's always the answer? Positive infinity. Same way with natural log. If you're going to positive infinity, you get positive infinity. But the trick was, if e went to negative infinity, what was the limit? 0, because it follows the asymptote. And then if you recall, natural log just reverses. You have to have a limit going to 0, and you end up with negative infinity. Okay. Those you might want to keep in front of you because you are going to see a ton of those. Because you're going to get problems like this. Okay, so you're going to get something ugly like that. This is not a problem we could have done by any of our other limit methods. If you put 0 in there, what are you going to get? What's e to the 0? 1. So I get 1 minus 0. So that means I have a 0. And on the bottom, if I do cosine of 0, cosine of 0 is 1 minus 1. So it is 0 over 0. It's indeterminate. You have to make sure it's indeterminate. You have to do that step, show me that you got 0 over 0 or infinity over infinity.
Well, they asked about that,
Yeah, they all work. It's 15 minutes, but I only got 2 minutes left, so we're going to go. So you're going to go then, oh, I can do L'Hopital's rule. I can take the derivative of the top. So just derivative of the top. What's derivative of e to the x? E to the x. 1 is nothing. Minus 1. Okay. Derivative of the bottom, derivative of cosine would be negative sine of 2x times by 2, because you got to chain rule it. And then the 1's going to be gone. Okay, now put 0 in. See if we got somewhere. 1 minus 1, okay. 0 in sine of 0 is 0. I got 0 times 2, so I'm still at 0 over 0. So guess what you do?
You go back
Still
and do the
indeterminate?
conjugate or?
You go do it again. You do the derivative of this. You just keep doing it until it works.
How many times are we gonna have to do
somebody sat down and
No more than 3. So derivative of e to the x would be e to the x. Okay. Now the bottom, that 2 on the back, that really could be just written up here as negative 2 sine of 2x. So when you do the derivative of that, what are you going to get? Cosine of 2x times 2. Yeah. Okay, so now put the number in. Ooh, e to 0 is 1. I'm going to get an answer of something here. Put 0 in cosine. 1. So I really have negative 2 times 1 times 2, which would be negative 1/4. And it comes out. As long as you're getting 0 over 0, infinity over infinity. Somewhere at the end of your assignment, you're going to start hitting problems where you've got 2 things that are coming out multiplied. Don't do those. I can text you later if I need you about what problems not to do. But I didn't get to show you what you do in that situation. Okay, text you with what not to do. All right. Okay, it would be the same thing. It's just that when you sub the number in, like maybe you would end up with, instead of 0 over 0, you would get infinity over infinity. It's the same thing. You just do the derivative of the top and the bottom. It's exactly the same. No difference. And like I said, we're doing lots more L'Hopital's next class. So